we are given a graph of a function f of x, and we're asked to answer some questions about that. So the first one we want to do is evaluate f of 5. Okay, so remember this means that this is the x value of 5, and we're trying to find the corresponding y value. So if we look at our graph, we have the point 5, 0. So that means that f of 5 equals 0. Okay, now for the next part, we want to evaluate f inverse of 7. So remember, an exponent of -1 with a function, that's read as f inverse. It is not reciprocal. It's same notation to mean a different thing in the context of a function. So now to do f inverse, we are not given the graph of f inverse. We are given the graph of just f. So the idea is x's and y's reverse roles when we're doing the inverse functions. So instead of what's on the inside of the parentheses being the x, like when we're asked to find f of 5, what's on the inside of the parentheses, we have to think of that as the y value when we're looking at the graph of f. So to evaluate f inverse of a number with the graph of f, think of what's on the inside as being the y value of the point, and now we want the corresponding x value. So f inverse of 7. I have a y value of 7 here, and the corresponding x value is -7. So f inverse of 7 is -7. Okay, now we want to evaluate f of 0, so we have to be real careful here. This is using the original function f. So again, with the graph of f and evaluating f of 0, the inside of the parentheses is my x. So when x is 0, what's the corresponding y? And I have the point 0, 3, so that means f of 0 equals 3. And then the last one to evaluate is f inverse of 0. So again, using the graph of f to evaluate f inverse, what's on the inside of the parentheses is the y, and we're looking for the x. So I have the point 5, 0. So when the y value is 0, the x value is 5. And f inverse of 0 equals 5. Now if we look at a couple of these points together, notice with this, f of 5 equals 0, f inverse of 0 equals 5. These are referring to the same point, the point 5, 0 on the graph of f, but the interpretation is different depending on if we're using the function f or the function f inverse. Also notice the notation here. You should have f of whatever or f inverse of whatever equals the corresponding number. Don't just list the coordinates of the point. I'm looking for you to tell me this represents what number. Okay, so there's one more problem here. So on the same set of axes, we want to sketch the graph of f inverse and label any specific points that we can find with their coordinates. Okay, so again, this goes back to the whole idea of, I'll even write it here, x and y, we'll say change places, or switch. So in all of the points that I've been given on the graph of f, I'm going to change the order of the coordinates to get a corresponding point on f inverse. Okay, now, I'm going to put this on my graph. First I'm going to do specific points. I'm going to use a different color. The graph of f has the point -7, 7. So that means the graph of f inverse will have the point 7, -7. So if I go over here to x equals 7, but I have to go down -7, so it'll be just under this other point. And I put that in red. Okay, and let's see, I do want to label that. Let's see if I can squeeze it in here. That's 7, -7. The original graph of f has the point 0, 3, so the inverse is going to have the point 3, 0, which would be right here. Okay, that's the point 3, 0. Now 2, 2, that's interesting because the x and the y are the same, so that point is not going to change. Instead of the point 5, 0 on the graph of f, the graph of f inverse will have the point 0, 5. And lastly, instead of the point 7, -6, the inverse graph is going to have the point -6, 7. So again, it's going to be close to this other point, but now on the other side of it, so negative 6, 7. The other thing that we can do to help us get the graph of f inverse is because the x's and the y's change places, if we graph the line y equal x, we can think of reflecting the graph about that line. So the graph y equal x cuts through the origin. I'm going to put it as a dashed line because it's not a part of the graph of either f or f inverse. It's just a reference for the sketch. So it goes through the origin at 45 degrees, and notice it would go through the point 2, 2, and all of the points where the x and the y values are equal, because that's the line y equal x. Okay, so now to finish off the sketch, I've got these points for reference, and I'm also going to use the idea that I'm going to reflect over the line. So anything on one side of y equal x for the original function will be on the other side of the line for the inverse, and vice versa. Alright, so let's see. Connecting my points here, I'm going to start over this way. So if I reflect this portion of the graph, it's going to do something like this, and I have points to shoot for. So I have this point that I hit here at negative 7, 7, or sorry, negative 6, 7. And then I come down and I hit the point 0, 5. And then from there, I've got to hit the point 2, 2. Carry on to 3, 0. And then over here to 7, negative 7. And of course you see some symmetry going on here because I've taken a graph and I reflected it. Right? So that is how we get the graph of f inverse of x.